this is exciting. I'm talking to you live from Etsy HQ here in Brooklyn, New York. And about one room away is Mike Brittain, who's going to be talking a little bit later about various things. The best part about the online conferences, I think, is that in a world where there's only one Velocity conference per year, at least in the U.S. Now there's one in Europe, and there's been one in China. There's still a huge amount of time in between those conferences, and operations and performance doesn't stop just because there's no conference going on. So this allows us to get a lot of speakers to talk about a lot of different topics that we wouldn't possibly be able to cover elsewhere. The other thing that I want to point out is that what's great about this online conference is that we've got a lot of operations-focused content as opposed to some of the more recent ones, which is normally Steve Souders and a lot of performance, all good content, but it's great to have sort of returns to some operations content as well, so that'll be great. So in sort of looking at the program we got here, we got 4 excellent speakers and great talks that I'm excited about. It struck me that there's somewhat of a theme, and one of the themes that we have in sort of all forms of engineering, especially in operations, is this idea of situational awareness, and where you are in the system, how a system is behaving helps you anticipate problems and outages, and how you're going to work yourself sort of in the future. And sort of along that themes, we've got Mike and Vladimir is going to go over various ways to gain this sort of situational awareness from the application stack in forms of metrics and different approaches for that. Dave Apgar is going to talk about something a little different, which is geographic awareness and behaviors with large-scale systems. And Kate Matsudaira is going to talk about something that's usually overlooked but extremely important. One of the reasons why we brought a culture track into Velocity was for a lot of the things that Kate's going to talk about, and that is certainly situational awareness or more personal awareness about how your organization, how you are part of this system, right? There's a human element, there's human discretion in the design and building and maintaining of these systems. Without further ado, I'll turn it over to Mike Brittain, who's gonna start his talk with a very, very old joke. Mike?
Hi, John. Thanks a lot. Just make sure I'm getting the slides up here. All right. Hopefully, we're getting started here. Yeah. So I'm gonna be talking about logging today, and this was not really a talk I slated for being on an online conference. I figured this would be a little bit better as a stand-up routine. So the joke doesn't really fly quite as well if you know the old "take my life, please" joke. And online conferences are kind of foreign to me. I haven't really done this myself on this side, so I figured I'd kick off by kind of making the glass go one way so you guys can see. Like John mentioned, I'm calling from Brooklyn, New York, and we're out at Etsy. And I'm talking on an enormous plush telephone that we had made up. We had somebody from Cisco put this together for us. It's a nice voice utility. Hopefully you can all hear me all right. And like I said, we're going to talk about logging today, application logging and error logging. And first thing you might think is this sounds like it's going to be a really, really boring talk, and you want to cut out and maybe just check out the slides later. But seriously, there's a lot of information in here that I think is worth listening through, and this is going to be a really pretty technical talk. I'm going to have a good bit of code and some tooling that you can use. And don't worry if I move through the slides a little bit quickly, because I'm going to have these up on SlideShare right afterwards, and I'll post the link to them in the chat so you can all get to them and see the actual details. Just a quick overview. Like I said, I'm calling from Etsy, and if you're not familiar with Etsy, we're an online marketplace where people can sell their own goods. Primarily, everything is handmade. Very, very clearly, we're a marketplace for things that are not mass-produced. So it's a lot of sellers who are creating their own goods and selling directly. And it's a very active marketplace. We're doing around 25 million uniques a month right now. We actually have sales, people selling and people buying across 150 different countries. And last year we did just over about $300 million in merchandise sales, and quite a lot of that goes out directly to the people who are selling. So this is, like I said, this is a really active marketplace, and we care about operability. Our stack looks a little bit like this. It's generally a pretty simple, straightforward LAMP stack with a couple of exceptions in here. And since today we're going to be talking about application logging, primarily this applies to, for us, the things I'm going to be talking about apply to Apache and in places where we're using Gearman for offline tasks. These are jobs that we can kind of queue up in the background out of band with a standard web request. And when those execute, we generate logs that are very similar to our Apache access logs and error logs. Don't get really hung up if this doesn't look like your stack, because I think a lot of the same principles that we're using can be applied pretty much anywhere, and I'll go into those details in a little bit. So we have some engineering priorities at Etsy that sort of drive our direction with how we deal with application logging. The first of which is we're constantly pushing new features to the site. We've got about 90 engineers who are working on the site. We deploy code every day, multiple times a day. And as we're changing things, either building new features, testing new features, or maybe we're testing an experiment that maybe 50% of users are seeing one thing, 50% of users are seeing another. Maybe we've got 1% of users seeing something. We want to know, essentially how things are working across those features and those user groups. As my abstract said, I'll talk a bit about performance, because that's really important to us here. We've spent a lot of time in the last 2 years refactoring a lot of our code base. We're about a 6-year-old company right now, so we've gone through a couple of iterations of code, and we spent a lot of time reworking some of the underpinnings of the site. And as we're getting to the point where things are solidifying, we're looking really hard at performance in places where things have gone maybe wrong or could be going better. Operability for us is huge. Like I said, we're an active marketplace. In August, we did about $45 million in sales, and that equates to around like $1,000, a little bit over $1,000 a minute. So what we're looking for are tools that give us really high visibility, as near real time as possible, to know that if we do something that goes wrong or something happens to our hardware, we can recover from it quickly. And our logging goes into that as well. And simplicity is an underlying theme in a lot of our tool sets here. We put a lot of operational expectations on our engineers. And so, even though they're busy building features, we have to ensure that the tools that we're asking them to build in terms of monitoring and logging and trending are really simple to approach, and that it doesn't seem like a big time sink for them. So just, again, to cover up here, we're going to be talking about a lot about logging, and we'll talk about how we can build trends out of that as well. These two things are really complementary. We love real-time graphs. We love looking at data porn all day long. We have people who sit around at their desks over lunch and just stare at graphs as they tick across the screen, understanding how different pieces of the site work. But we generate a lot of these trends from our logs, and we love having the logs behind the scenes as well and available, because then we can go back to the source, and when we see something go wrong, we can really dig in and do a deep dive with some of our higher-powered tools. And we're going to talk about app logging. Again, for us, this means specifically, I'm going to get into this in just 1 minute, this means very specifically Apache access logs and error logs. And again, we correlate the same, we sort of work with the same formats in Gearman, but these will be specifically examples that are done in Apache. And if you're familiar with Apache access logging, I believe that the default log still looks like this. This is a common log format. All these little format parameters in there are different pieces of information that go into your logs. Things like the time, the IP address of the user connecting to your site, the number of bytes that were returned, the HTTP status code, things like that. This is very, very basic stuff and doesn't really get you far enough. The combined log format is a little bit better because in the same log you get the HTTP refer, so you can see how people are clicking through your site essentially, or where they're landing from other sites, and you get to see the user agent. So there's a little bit more information you can glean from there, but not a whole lot. So the log config module in Apache actually gives you exposure to tons of information that you can augment your log format with. And so a couple of examples here, like %f will get you the file name that's being requested, not just the URI. And %k will, if you're running Keep Alive on your servers, it'll let you know in each request what stage you are in the Keep Alive connection, how many requests have been served on that connection. And if you get %T, you get the time taken to serve the request. And note that this is in seconds, and seconds is actually not really that useful to us. So there's another one, and John pointed me at this yesterday, which that I might have an issue with this slide. This may only apply to Apache 2 and later. So if you're working in 1.3, this might not apply to you. But %D will get you the time to serve the request in microseconds, which is actually really a nice fine-grained piece of data. And then this is where we really get interesting. We have this parameter that allows you to put the contents of an Apache note into your logs. And Apache notes are like this way of passing information between different modules in Apache. So different modules can set and read these notes, and we can set those from PHP directly. There's this amazing, I say amazing function in PHP because once I realized we could start using this, we were able to expose a lot more information into our logs, and our logs became, like 10 times more useful than they used to be. So Apache Note is really, really simple. You just give it a name and a value, and then you accept that into your log format, and that shows up in your log with every request. If you're creating that value in PHP and calling Apache Note, whatever you pass in is going to show up in your logs. So this is our steroid log format. As you can see, there's a lot more in here than there was in the combined log format. We've added in a number of different Apache notes in here. I'll talk through a bunch of these, but as I started off, I'm really interested in performance here. So two of the notes that we care most about and that we actually do the most reporting on are the number of bytes that were consumed while generating the page in PHP, and the time in microseconds that was used in generating the page response in PHP. So I want to show you exactly how we do that. I don't really consider this much of a secret. This code is pretty close to the original that's in our code base, although I've adapted it slightly so it'll be a little bit more readable on these slides. At the very top of any request on our site, we just set a timer that has microseconds resolution using microtime. And then to catch the end of that timer, because we could end in a number of different places, we register a shutdown function in PHP, which will actually execute even if your script is failing or you found an exception. This code will still execute, so you can capture the page time here. And so we have this function called page stats, and obviously the first thing we want to do in there is calculate the difference in microtime at the time that the shutdown function is being called, and get the difference of that in our initial timer. And then, like I said, we call Apache Note, and we take PHP microsec, the name that we put into our log format, and we put that time, the diff variable, and that spits the time right into the log format. And at the same point, we don't actually have to measure the memory because PHP has a function for grabbing that. So we just inject that into the log as well at the same exact time. So I mentioned earlier we've got this %D in log config module. Why aren't we using that? Well, we are using it, but there's a distinction you have to be aware of, which is that %d is actually the time taken for Apache to receive and return a response. And what we're interested in mostly is from our engineering side, is what kind of time are we taking up in PHP? How long does it take to build a request? If you look at %d, what you actually end up having is the time in PHP plus any of the time taken for your response to be buffered to the network, which if you're, depending on your network configuration, that might be fine. You might just be buffering to something, a local proxy of some sort that's going to hand off the rest, and Apache will wipe its hands. But if you have a different kind of network configuration where your webs are a little bit more exposed directly to the network, what I've seen in the past is like we had a really slow web crawler at one point on a site that I used to work on that opened connections to Apache, but had a really, really slow connection. And so Apache would just sit there trying to hand off data to the network. So in that case, %d looked really, really horrible, even though generating the response was really fast. So back to our steroids log format, there was a bunch of other things in there, and I'll call a few of these out specifically. We put the user ID of whoever's logged in, just a numeric ID for us, into the log format. And generally, if we really want to track down something that's going wrong, sometimes we see it's particular to just one or two users. But what this also gets us is that the values in the log file are either going to be a dash when somebody's not logged in, or they're going to be a numeric value when somebody is logged in. And we serve different responses to people who are logged in versus logged out. So this gives us a way of segmenting our log data and our performance data based on whether a request was for somebody who was logged in or logged out. We do a lot of the segmentation. The request UID is another piece of data that we put into every single request. It's not something we segment on as much. It's a string of about I think it's about 32 characters of random. And what this does is it helps us correlate across the error logs, and I'll talk about that in a couple of minutes. That'll make more sense. But just know that value is here. But back to segmentation, we also have A/B selections. So like I said earlier, when we're testing new features, we have, sometimes you'll have half of your user base getting one response, and half of your user base will be getting another response, but it'll be the same URL. So we can segment using this particular item in our log format. We can segment across all different types of A/B tests that are happening for that particular user. So we might have this particular user who is getting the easy version of online registration, but they're not getting the personalization widget, but maybe they want the icon in core flower blue. Those are the types of things we can segment across there. And we have a couple more. This slide actually I found out this morning was a little bit, the line ending got screwed up a little bit here. But we've got two more that we're working on adding shortly. This summer, or late this summer, we launched two pretty large features for Etsy. One was that we now serve the site in German, and that serves from the same set of web servers and the same URLs and everything like that. And as we expand globally, we're going to want to know whether we're serving a request to somebody in the U.S. or somebody in the UK or someone in Germany or any different country. And the other big release we had this summer was that we've got a web application that runs, and again, this runs in the same set of servers using the same URLs. So knowing the difference between a request that's for desktop or mobile is important, because in some cases, in mobile, we care a lot more about smaller response sizes and fast response times. So there's going to be differences in what we serve. And by the way, these are open tickets right now, so if anybody's out there and is interested in doing this kind of stuff, we have some openings here, and come on in and help us out. So hopefully you're still following along. You haven't given up yet if you're not using Apache and PHP. If you're using something else, the point that I want to make is that you can get all this stuff in one place. It doesn't have to be a built-in access log, but you can have your own logger write this stuff out. And the important parts are listed on the slide. things like when the request happened, what the HTTP method was, the request URI, all the kinds of things that are in our log format, plus the custom segmentation fields, whatever is important to your business and your engineering team. So what do we do with this? We actually internally here, we use a fairly large commercial product for a lot of our log parsing. But if you're just getting started with this, there's a lot of data that you can get at very quickly with some pretty standard tools. And so I want to talk about how you can put together a very lightweight pipeline to get at something really useful here. So like I said, there's actually 3 numbers at the end of every line in our log format. They're the number of bytes that were taken to create the page that is being served, the time in PHP that was being used to create the response, and then the time that Apache took to serve the response. And so a quick average could be done. Let's say we wanted to see how many bytes were being consumed when we generate listing pages on average. We can just grep for /listing/ across our access log, and then grab the third to last column out of there and average that. And what we get is a number of bytes that are taken on average across whatever segment of our logs we're looking at. And if you want to get into graphing, which I think is really the goal here, we can grep again for listing pages. In this case, what I'm doing is I want to generate a data set that I can consume with GNU-plot. So I'm going to grep for specifically listing pages, and then I'm going to do a little bit of regular expression substitutions on the timestamp, so I can get it to basically an hour, minute, and second. And then I'm going to print the timestamp and the time in microseconds taken to generate those results into a file. I'm just going to put it in page_time.dat. And my apologies, but I would have liked to have the result set in there just so you can see what the format looks like. I'll add that in for the slides that go up on SlideShare. But we can put that into a really quick recipe in GNU-plot. It reads in from that file. You can go through this later. But reads that file and creates a graph, and we get this nicely formatted distribution of all the times it took over about, about 10 minutes of logs, all the times it took to generate listing pages. And what you see here is kind of interesting. We have a pretty thick band between about 250 milliseconds and, say, 600 or 650 milliseconds. So a lot of our responses fall within there. And then there's some outliers. I painted a red line across this graph, which is right now we try to keep an SLA of 800 milliseconds for every page on our site, and that applies to the 95th percentile. So it looks like we're doing pretty good here. Like pretty much everything is falling underneath that SLA. And something interesting, the great thing about graphing is you start to see, you can visualize anomalies. And one of the things you'll see here is that there's this other little tiny band at the very bottom that's right around 100 milliseconds. And when I dug back into the logs and looked, well, why are we getting some responses that are really, really fast and then a couple others that are not? What I didn't do was filter out only responses that were with a 200 response code. So what you're seeing here is actually points where we've had legacy URLs for listings that our page is seeing the URL, and then just issuing a redirect to get the user onto the right, new canonical URL. And so those redirects happen very, very quickly. And so you're seeing this, this extra band of responses that happen in only about 100 milliseconds or so. So I'm going to move on to error logs. This is the other half of our logging talk here. And we end up just basically putting all of our PHP and Apache errors into one file. We don't really try to distinguish too much between files. We do have a bit of a bottleneck if we use syslog-ng to aggregate logs onto a central server so that we can have engineers get to that server easily and see everything in one place. And anytime we create some new file, we have operations guys have to get in and set up the log aggregation. And so we try to just centralize everything into one place. Again, the idea is to keep things simple. If you want to add some new logging, just throw it in the same place, and we have tools that will help filter out. And the only place where we do diverge from that is that things that are truly errors, we do keep in a single file that's our error file. And then things that are more informational messages, things that are less, things that we can't really react to very easily, but we want to know that they're happening, we keep all that in our info file. And then in development, we also have a debugging file, which has all sorts of things just being spewed into there. So we want to track in every error that we're logging. We want to track the level of the error, and then we also want to track some kind of arbitrary namespace that gives us an idea of I want to see errors related to SQL or performance, or maybe I want to see things that come from a specific class, and we use this class keyword in PHP as a namespace. And so our code actually looks like this. It's one line in our logger class. The error is we use the namespace actually as the method, and then you can see we've got this namespace SQL long query that we append after the message that's being logged. And just a quick note to point out here, if it takes more than one line, and this is a wrapped line, but if it takes more than one statement in your application to do logging, then you're probably putting too much work onto your engineers. And it may sound silly, but all of our logging and metrics collection on our engineering side, in our code, we want it to essentially be one line. Just, this is the thing I want to log, or this is a stat that I want to create a graph out of, and not have to think about creating a big object and doing a bunch of other nonsense to it. So when we take a look at what the output looks like, we've got these columns that we put into our error logs that show the error level and then the namespace, and then a couple other pieces of information in here. Obviously, the timestamp. It's really important to know, obviously, when the errors occurred. But the hard part is when you see a bunch of errors show up and you want to correlate them back to what request was made to cause that error, it's kind of not so fun when you want to go back and grep for that particular timestamp, because if you've got a lot of logs that are aggregating together, you might get a lot of rows. And this is a slide that wrapped improperly, but this is grepping for a timestamp against our access log and piping that to word count with a -L, and that gives us the number of lines that were returned. So in this case, over 1,500 lines that might have been associated with some particular error. So getting back to what I was saying before about a request unique ID, we put the same request unique ID into every error log entry as we do in our access logs. So essentially, this gives us the ability to join across error logs and access logs across that request unique ID, which means that if we see an entry in our error log, then we can go back to our access log and we can figure out what the request URI was and what A/B tests were being run and what user ID was logged in, because maybe one person has a cart and one person, another user does not have a cart. They're not working on making a checkout. And logs can get noisy when you start putting them all in one place, like I'm suggesting. But there's this, very handy flag in grep. It's -V, and if you've got namespaces, you can just ignore and filter out the namespaces you don't care about. Because when you start looking through your logs in real time, if you do like a tail -F, you're going to see something crazy like this. You're just going to see lines and lines and lines flying across the screen. Really not a whole lot of information you can glean out of this. You can see instances of errors, but you can't actually tell how many are happening. So the next tool I want to talk about is how we can turn that into trend lines. So we can see that out of this enormous number of lines that are flying by our screen, how many of those were fatals occurring in our application, or errors or warnings. And for that, we use a tool that we've open sourced here called Logster. And I want to give some particular credit, especially since Vladimir is on the call right after me. We took a tool that he worked on called Ganglia Logtailor and took it internally and actually stripped some of the features out of it, because, as I said before, simplicity in our tooling is super important to us. So what we did was we stripped it down, took out features that we didn't need, and made the parsing tools a lot simpler. So there would be fewer lines of code for an engineer to write if he wants to parse through a log file for a particular metric and graph that. So Logster is available on our GitHub account. It just runs by cron. It runs about once a minute for us. What it does is it just watches your log files and maintains a cursor on them. And every minute that we run it, it just chews through the last, the newest log entries that happened since that cursor, and then sets the cursor to the end of the file. And once we've aggregated data out of those entries, we can pipe them out to either Ganglia or Graphite right now. And obviously, we could extend Logster to do more than that. So, for example, we've got a log entry from our error logs, and we've got this error log level that we care about. And our parsing scripts for Logster start with a regular expression, and we want to get to that particular string, the log level. And once we have that as a variable, all we have to do is aggregate into some variables in the parsing script. So anytime that's a fatal, we increment fatals. Every time it's an error, we increment errors, and so on. And then we just return metric objects from the parsing script. So you can see, again, fatals are being returned under the name fatals. Errors are being returned under the name errors. Warnings, same thing. And what we get is this nicely nice trend lines for each of those items out of our error logs. And we don't just do that for error logs, but we also do this against our access logs. Like I said, we have a user ID in our access logs, so we can tell if we've got a signed in or a signed out user. And it turns out, as we would expect, that signed in users, it actually takes more time to generate their pages than signed out users because we have more information, more personalized information on those pages that needs to be displayed to the user. So it takes a little bit more time. We generate tons of these across our architecture. And for example, this is what a dashboard looks like for us. We have some very lightweight dashboard code that's also on our GitHub account. All it does is it allows you to dump a bunch of different Graphite or Ganglia or Cacti graphs onto a single page, and it takes care of refreshing them, once a minute or so. And so you can correlate all these different metrics together. And this page is an example of a few of our metrics for specific areas of our site. So we've broken down page performance, page generation time for listing pages and shop pages, and we do this for a number of other areas of the site. But we've got those all correlated together in one place. So I want to wrap up. Just to sort of reiterate everything I've been talking about, you should be logging a ton of data into your files, and there's no reason why you can't just put it into one place. It's really, really more important to get this data and do it quickly and simply than to worry about how many files you have or something like that. And don't just go with the default setup. Log custom fields. Log things that are important to you for how to split up and how to analyze your data. Have a way to correlate errors from your error logs into specific requests, so you can track back when something's going wrong. When you see a trend line go way up or way down, you can correlate back, to specific requests as to why that's happening. Make graphs out of this stuff. I mean, you have to be able to see what's going on. As that quick GNU plot example pointed out, you can see anomalies when you make this stuff into graphs. Logs are really hard to judge that way. And convert rates to trend lines. If you've got lots of logs, obviously logs are going to be appending all the time, and you want to see how often certain events or certain problems are happening. So work out a tooling so you can convert those to trend lines, be able to look at those in real time. And these are all samples that I hope that you can take away. Please steal from this. This is this is great stuff. This is a great starting point, and it's not the end point. There's much more you can do from this. And that's what I have today. So I don't actually know where we are with time, but I hope that we have a couple minutes for questions here. I'll mention that. Are we over?
We're about over. As we get used to this online conference, there's a reasonable there's a couple of questions in here, and I think it might be worth to take to take one of them before we get on. Actually, it turns out that there's a decent number of Etsy folks, Etsy engineers that are in the chat room helping to answer some questions.
I'm also happy to hang out in the chat room a bit and answer questions as well. So feel free to fire away there.
Yeah, I think that'll be helpful. There's a decent number of questions about retention. Dave Zwieback asked, is there an Apache Node equivalent for other languages, for example, Python, that you're aware of? I think that somebody had mentioned that in the chat that there was. But I don't know, Mike, unless you're aware of other languages besides Python.
I did a little bit of research before this because I think it's such a handy utility in PHP to be able to do that. I actually couldn't find something, but I don't have a deep knowledge of Python or Ruby or other languages you might want to do this in. There may be, but I believe that this is Apache nodes are specific to languages where you are running a module in Apache, and so I think that starts to fall apart when you're not in a language that's being executed as an Apache module. But that doesn't mean you can't approach this other ways.
Right. Another question was, do you have automatic registration in an issue tracker based on log errors, based on all the info you're gathering?
That's an interesting question. Automated, like an issue tracker?
Yes,
not
an issue tracker.
No,
okay.
that doesn't sound like something that would be out of the question.
Again, I think a bunch of people sort of jumped in on these questions. Are you logging Apache child activity, so average utilization, lifespan, death in any way?
Not in our logs. I'm not sure. I would actually defer that to our operations director.
We'll have to ask him. Okay, great. So great. So that would be awesome, actually, Mike, if you could hang out in the group chat as well. And let's continue on with the goodness.